Hello, everyone. How are you guys doing? You can actually unmute yourself and talk. Don't be shy. Hi, Awa, Jack, Jenny, Jody, Mary, Samaya, Zoe, Louise, Michael. How all of you are doing?
Good, how are you?
I'm doing fine, thank you. I'm so sorry for this sudden request to be on. And I hope I will able to help you as much as I help you in class, or maybe even better than that. So anytime if you don't understand anything, please stop me and ask me a question. You don't have to type it if you don't want to. You can simply unmute yourself and ask me. But if you're uncomfortable unmuting yourself, simply type it on the chat box. Hi, Judy. Where can you find the worksheet? It's on Lumen. So if you log into Lumen, you'll see there's a yellow bar. Wait. See the yellow bar? The yellow bar has all the worksheets. Yes, I'm going to post this recording and I'll also email you. Okay. So when I convert my computer into a tablet, I will not able to see the chat box. So don't send me a private chat. Write the whatever you want to say, write it on the public chat so I can see it from another computer. But if you write it privately, I cannot see it from the other computer. Okay. So today we are going to do week 9. And week 9 talks about identities, half angle, double angle, and some difference identities. Yep, that's it. So did you guys go over that in class with your lecture instructors? Half angle, double angle, some difference identities. Do you remember seeing them in class?
No, we didn't go over that.
Not yet. So am I
No.
edge of the so we did this in our last class, which was 8. Oh, probably you're gonna learn it today. Okay, then I will introduce you to the topics. It will be fun. So, trigonometry is all about identities, mostly. If you want to do well in trigonometry, you must remember many identities. So in our last class, we learned a few identities like the reciprocal identities and quotient identities, like sine is 1 over cosecant, secant is 1 over cosine, those things. And we also learned that sine square plus cosine square is 1. And we proved one identity that 1 plus tangent square is secant square. So like those, we have other identities. We call them sum or differences. So sum or difference identities, let me write them here. Sum or difference identities. Let me make it a little thicker. So one of them is if you have two angles, A plus B, it's so sine is very generous. Anytime we give sine any angle, any two angles, it says, well, I'm going to take one and give one to cosine because sine and cosine, they're friends. So we get sine of one of the angle times cosine of the other angle. And then since we get both angles to sine, but here sine took only one of them, so we said, well, this is not enough. We have to get more. So we add another portion. Now sine gets the second angle and cosine gets the first angle. In other words, since we are giving two angles to sine, we want sine to use both of them. So sine take one of them, give another one to the cosine. And then we add sine take the second angle and cosine take the first angle. If you want to subtract like sine angle A minus B, that is same thing, you just have to subtract that. Okay, so sine A cosine B minus sine B cosine A. If you're adding them, it's sine A cosine B plus sine A cosine B. So these are the two sum and addition for sine angle. Next comes sum and addition for cosine. Cosine A plus B. Now, cosine is selfish. It doesn't want to share its angle with anyone. So it takes both angle. Cosine A times cosine B. But if you observe, in your family, if you have two kids and one of them is selfish, we always force them to share their toys with the other one. So we force cosine to share its angle with sine because sine was so generous and shared his angle with cosine. So we want cosine to share the same thing, do the same thing with sine. But cosine says, well, you know what? I'm selfish, so I'm not going to give exact same thing. So he subtract and then he gives the two angles to sine. So first it takes both angle for itself and whatever it means, it subtract that and then gives the two angles to sine A, sine B. In other words, if you add two angles for cosine, you get a subtraction in the formula. And if you subtract two angles for the cosine, it does the opposite. It adds the two things in the formula. So sine and cosine double angles are this. Tangent, I don't remember. So I'm gonna skip tangent double angle. Plus, we don't use tangent double angle much. So I'm going to give you double angle now. So these are the sum and difference. Now here comes double angle identities. Double angle identities. You're gonna find all the identities in your book or on Lumen. So sine double angle. We always seen sine x only. Now this time it's not only sine x, it's sine 2x. Instead of x, we prefer using a. It looks professional. So sine is always generous, okay? It doesn't matter what we give to sine, it always shares the cosine. So the formula for sine double angle is 2 times sine of that angle times cosine of the same angle. So the 2 comes in the front and is sine of the angle and cosine of the angle. Now, cosine double angle is different. It has 3 formulas. You can use any one of them. My favorite one, which I always remember, is cosine square of the single angle minus sine square of the angle. And it's my favorite one because I can remember this from another identity. We have sine square plus cosine square is 1. So when we add them, it becomes 1. But when we change their position and we do cosine square minus sine square, it gives us the double angle for cosine terms. Okay, so that is my favorite because I can easily remember them. There are 2 others. I'm not going to show you here. You're going to see them in class. So whichever you prefer, you can use that. Now for tangent, you don't have to memorize that because you can simply use sine double angle over cosine double angle. But let's say you don't want to use sine and cosine, then you have to memorize. Actually, for your exam, you don't have to memorize. They're going to give you cheat sheet. In that cheat sheet, all the formulas will be given. So we have 2 tangent on the top, and on the bottom it's 1 minus tangent square. So this is x, not x, a. My bad. A means angle. So it's tangent a, and then on the bottom we have tangent square a. So double angle for trig. And if you know sine, cosine, tangent, you're fine. You don't have to know the other 2. Then we have double angle, half angle. Half angle, let me do it below. Half angle identities. Half angle is kind of weird. It's kind of weird because the angle, actually, the sign of the angle depends on which quadrant you are lying. So if you're looking for sine half angle, so angle divided by 2, that's a half angle. If it's on the first quadrant or second quadrant, the answer is positive. 1 minus cosine x over 2 under the square root. But if the angle is lying on the fourth quadrant or third quadrant, then it will have a negative sign. So we know sine is positive here and here. So in these 2 quadrants, it's positive. But if your angle is lying in the third or fourth quadrant, then it will be negative. Whatever answer you have, the sign will be different. Same thing for cosine. Oops, I forgot to get another page. All right. Such. Great. So sine half angle is this. Cosine half angle is same thing. If cosine is positive on second quadrant, so all students take calculus and this too. Cosine is positive in those 2 quadrants and it's negative in the other 2 quadrants. So if your angle is lying on either one of them on first or fourth quadrant, answer will have a positive sign. But if your angle is lying on the second or third quadrant, your answer will have a negative sign. And the formula is 1 plus cosine x. Sorry, this is A because I'm writing my angles in A. Cosine A, we take half of that and take the square root. So for sine, we subtract 1 minus cosine, and for cosine, we add 1 plus cosine, and we take half of both of them. For tangent, if you don't want, you don't have to memorize it because you sine over cosine. But if you're not using sine over cosine, then it's 1 minus cosine x over sine x. And here we don't use plus minus because we don't have the square root. Okay, so for square root, you have two choices, either positive or negative. But tangent doesn't have the square root. Thus, we don't have a plus minus. Depending on where we have tangent, our answer is positive or negative. Any questions so far? So I didn't do the method. I just introduced you to these concepts. Now, once you know all these identities, then you can do any question. For example, on the left, on the worksheet, in question 1, it says use some different identities to find out how much we have for these angles. Unfortunately, without calculator, we have no idea how much the angles are, or without our unit circle. So instead of using unit circle or calculator, we'd like to do them manually in easier way. So which one you think look harder? A or B? A? Okay, wonderful. So question 1A. We are given sine 11 pi over 12. I am very bad at radian. I don't see radians when I close my eyes, but I will see degrees when I close my eyes. So I always convert my radians into degrees. So convert radians to degree if you are bad like me. So we have 11 pi over 12. In order to convert radians into degree, we need to cancel the radians. So radians goes to the bottom, so you can cancel them. And 180 goes to the top. So we have 11 times 180 over 12, but 12 goes to 180 15 times. And 11 times 15, let me check my work. Is it correct? 180 divided by 12 is 15. Perfect. 15 times 11 is 165. So 165 is less than 180. So it's somewhere here. This is our 165 degree. And they want us to find how much is the sine of that 165 degree. Unfortunately, even the unit circle doesn't have 165 degree. So we cannot even use unit circle to figure this out. So we are looking for two angles that will give us 165. But those two angles, we already know them, either from unit circle or from the special table or from the special triangles. So two smaller angles we need to use to get 165. So this is same as sine 165 degree. And now, which two numbers, if you add or subtract, you get 165. Either one of them is fine. Any suggestion? You want two angles. If you add them, you get 165. Or if you want to pick another two angles, when you subtract them, you get 165. Gosh. Any suggestion from anyone? Come on, guys. It's basic math. We're not doing any trick yet. 180 minus 15. Unfortunately, we don't know what is 15 degree. So our goal is to use 90 degree, 30 degree, 45 degree, 60 degree. So especially these three. And for the 90 degree, we have 30, 90, 180, 270, 360. So these are these four angles, the peak. And if you, besides them, we are allowed to use 30, 45, or 60. So using these 7 types, which one would be easier to break down our 65? How about 90? 165 minus 90. What do we have? 75. Okay, that means we need more 75. Oh, am I right? 165? I feel like the answer is wrong. 11 pi over 12. It should be in the thingy, unit circle. So let's see, did I make a mistake here? 11 pi over 12. 11 times 180 divided by 12. What I'm doing? 11 times 180 divided by 12. I didn't make a mistake. Okay. Which two angle gives us 165? 180. Yes. And if that doesn't work, then you have to do more work. So we have 180 and 15, right? But 15, 180 plus 15. Oh no, 180 and 15 is 195, so it's not 15. So let me see what happens if you subtract 180. 180 minus 165. Oh. Oh, I did plus. How stupid I was. What else we can do? Um, 60 plus 45 is 105. Okay, I don't see any easier way. So 165 is smaller than 180. So 90, 165 minus 90, 75. Okay. 120 plus 45. Say we don't have two numbers from the list. It's okay, I'll stick with your first one. 180 minus 15. So if we do that, the identity says it's sine 180 cosine 15 minus sine 15 and cosine 180. Now 180 is easy. It's on the left end of the thingy, x-axis. So at this corner, our x value is -1 and y value is 0. That means sine represent y. So our y here is 0. So cosine 15 doesn't even matter because this is 0. Then we have sine 15 and cosine 180. So cosine means the x. So x value at 180 degree is -1. So this negative and this negative, when you multiply, they turn into positive. In other words, we get positive sine 15. But we have no idea what is sine 15 degree. So we are going to use double angle again. So not double angle, sum or difference angle again. Why did it cancel out? So, okay, let me show you the details. Maybe I can show the details here. So we have sine 180 and cosine 15. So either you can look at here in the unit circle. So this is a unit circle. In the unit circle, every radius is 1 unit. That means this end where we have 180 degree, it has an x value -1 and our y value is 0. So sine represent the y value. The y value at 180 degree is 0. So this whole thing is 0. So we are multiplying 0 times cosine 15. 0 times anything is 0. That's why this first concept, the first part here, sine 180 times 15 is simply 0. And cosine represent x value. X value at 180 degree is -1. So this is -1. Cosine 180 is -1. Because here our x is -1 and y is 0. So -1 times negative sine 15 gives us positive sine 15. But unfortunately, we still have no idea what is sine 15. So we apply the sum or difference angle again. Now this time, which two angles, whether you add them or subtract them, gives you 15 degree. Any two angles from this angle list. Which two angles you take that will give you 15 degree. Sorry, 15 degree. We can take 45 degree minus 30 degree. 45 minus 30 is 15. So we can apply our difference angle again. We have sine 45 cosine 30 minus sine 30 cosine 45. Since it's a minus, so our formula has a minus in it. And now we are happy because sine 45 or 30, we can get them either using the unit circle or from quadratic form, not quadratic, special triangles. So I'm too used to the triangles, so I'm going to use the triangles here. One of the triangle is 45, 45, 90. The other one is 30, 60, 90. 30 degree has the opposite length 1, 90 degree has the opposite length 2. We add them and put it under the square root for the angle for the 60 degree. And 45 we have twice. Each of them get 1. We add them, we get 2 to the square root. We get the length for the opposite side of the 90 degree angle. So first we are looking for sine 45. So this is our 45 degree. Sine means opposite of our hypotenuse. So this 45 degree has opposite 1, hypotenuse square root of 2. So this one gives us 1 over square root of 2. Next we have cosine 30 degree. So this is our 30 degree. Cosine means adjacent of our hypotenuse. So this is our adjacent angle, which is square root of 3. And our hypotenuse is 2. So it's square root of 3 over 2. Then you're subtracting and you're finding sine 30 degree. So these are 30 degree here, but this time sine is opposite of our hypotenuse. So these are opposite and these are hypotenuse. So it's 1/2. Next, for 45 degree, this is our 45 degree, and cosine says it's adjacent of our hypotenuse. So adjacent is 1, our hypotenuse is square root of 2. Any questions so far? How did you get those? Any question from anyone? Then all we have to do is multiply. 1 times square root of 3 gives us square root of 3. 2 times square root of 2 gives us 2 square root of 2. 1 times 1 is 1. 2 square root of 2 is 2 square root of 2. That was where you were getting. Mohammed, what? Did you ask a question, Mohammed? No. Since we have the same denominator, we keep the denominator once and we combine the numerator. It's square root of 3 minus 1. So this is our answer. It's a bad color. Let me change the color to something lighter. Here. This is our final answer. We have no idea how much is this. Without any calculator, we want to know that. But this is the exact length we have for sine 165 degree. B is actually much easier than this, because in B you're going to apply the identities only once. Here we had to apply the identity twice because we didn't know what is 15 degree. Sine 15 degree, cosine 15 degree, we had no idea. So to find that out, we had to apply the sum of difference again. Are the triangles to specify cosine and sine? No, with this triangle, you can find sine, cosine, and tangent. And also all 6 1. Cosecant, secant, cotangent, you can find all of them. You just have to remember your expression. Sakatua. It means sine is opposite of our hypotenuse. That means if you're looking for cosecant, it's hypotenuse of our opposite. Cosine is adjacent of our hypotenuse. That means secant is hypotenuse of our adjacent. Tangent is opposite of our adjacent. That means cotangent should be adjacent over opposite. So you can use all six trig functions to get their values. You can use the triangles, just like the table. The special table I showed in our last class, it's same as this. Okay. Now, any other question on number one? No question for anyone? Now, question two, it's an interesting question, a fun question actually. It says we are given sine 2x cosine 7x plus sine 7x cosine 2x. They're asking us, what is this? From here, what do you get? So in order to answer that, all you have to observe is that you have sine and cosine together, and you have a plus. Sine and cosine together, and you have a plus. So which of the identities have sine and cosine, and they have a plus between them? Do you see? Can you relate the question with your identities? Which identity has sine A, cosine B, cosine A, sine B, and in the middle you have plus sign? Good job, Jody. Yep, it is sine A plus B. Observe sine A plus B is sine A cosine B plus sine B cosine A. That means the answer here is simply sine A plus B. Now, question is, which one is angle A? It doesn't matter. You can say the first one is A, second one is B. So it has sine 2x and 7x. And when you combine them, it gives you simply 9x. And that's all you have to do. You relate your expression with one of the identities and then simplify the identity. Any question? So how do you feel, guys, now about the new concepts you're going to learn today in your class? Good. A little nervous for the first part. Yeah, I believe in the exam, they're actually not going to give you this type of hard question. A is hard. Compared to A, B is very easy. So do be by yourself and see where you get stuck. You can ask me a question once you're done with this. Or if you think you can email me anytime. I'll explain that to you again about the email. Question 3 is another interesting question. It says we have sine of some angle. We have no idea what that angle is, but the length for that angle gives us 1/4. And the angle x is lying on the first quadrant. So somewhere we have angle x that gives us a triangle here. And since sine means it's opposite of our hypotenuse, So in this triangle, the opposite side of this angle is 1 and our hypotenuse is 4. So just by the first sentence, we have this visualization. We have an angle on the first quadrant that has a opposite side of the angle is 1 and hypotenuse is 4. How do you know? Because they told us sine of that angle is 1/4. And we already know sine in terms of triangle is opposite of our hypotenuse. Now they want us to find out that what is sine double angle and cosine double angle based on the information they gave us. Is the thing clear what they gave us? Any questions so far about the information they gave us? No? Okay, not yet. Wonderful. So remember, double angle has sine and cosine both. So here we are given only sine angle. We also need to find out what is cosine of the angle. Okay? Because if you observe the double angle for sine is 2 times sine x cosine x. I already gave you the formula before. So in order to find out the double angle for the sine, we need sine of the single angle times cosine of the single angle. Now we know cosine is adjacent of our hypotenuse. But look at the triangle. They didn't give us our adjacent side. So you have no idea what is the adjacent here. But from our previous knowledge, can we find out how much is the adjacent angle? What do you think, guys? What would be the length of the adjacent angle? How can you find this out? Any idea? Good job, Pythagorean theorem. So Pythagorean says a square plus b square equals c square. C means hypotenuse. So this is C, let's say this is B, and let's say this is A. So since you're looking for A, our A square is C square minus B square. And then we take the square root. Whatever we have, that's the adjacent angle. Sorry, adjacent side. We'll make it thinner. So our C is 4, we have 4 square. Our B is 1, so we have 1 square. Whatever we have, we take the square root. 4 square is 16, 1 square is 1. That gives us square root of 15. That means the adjacent side they did not give us is actually square root of 15. We were so smart, even though they did not give us, we still figured that out. Yep, square root of 15. Good job, Judy. You're doing the math correctly. Now, all you have to do for the double angle is that write them down in the equation. Sine double angle is 2 times sine single angle and cosine single angle. So it's 2 times sine x, which is 1/4 because they already told us that. And cosine x, now we know cosine is adjacent of our hypotenuse, and our adjacent is equal to 15, our hypotenuse is 4. So this is square root of 15 over 4. You can multiply them across, or if you want, you can cancel 2 with the 2 with the 4. So we get square root of 15 on the top, and 4 times 2 which is 8 on the bottom. That's the answer for sine double angle. Cosine double angle has the formula cosine square x minus sine square x. Now, when a trig function has a power, we can rewrite that this way, the whole function and then the power outside. So it's sine x and then the power outside. These two expressions are same. But then why did I rewrite? Well, I rewrote because I can see what to square now. Cosine x is square root of 15 over 4. And we are going to square that quantity. Similarly, sine x was 1/4. And we are going to square that quantity. That's why I rewrote them, because I can see what to square in my second line, which I could not see in my first line. So square root of 15 square gives us only 15, and 4 square gives us 16. 1 square gives us 1, 4 square gives us 16. Since you're the same denominator, we keep the denominator once and we combine the numerator. That gives us 14 over 16. They both are divisible by 2, so you can reduce them by 2, and we get it's 7 over 8. That is the answer for cosine double angle. Was anything unclear here? Any question, comments, anything? All clear so far? Wonderful. The next question says, use half angle to find out what is sine 15 degree. We already found sine 15 degree. Here, in this question, we found that sine 15 degree is this one. So never mind. Yeah, sine 15 degree and sine 160 degree is same thing. So here we did this question using somewhat different identities. Now they want us to find the same thing, but using half angle identity. So question 4, it says do not use a calculator. Without using calculator, using half angle identity, find out what is sine 15 degree. Well, we don't need a calculator because we're smart. We are gonna use half angle identities. And half angle identity, if you remember it from before, it says if we have, so 15 degree is in the first quadrant. So answer will be positive. So it's positive 1 minus, oh, sorry, my bad. I forgot to rewrite the first sentence. So sine 15 degree is same as it's sine 30 degree over 2. Right? Half of 30 degree is 15. So instead of finding sine 15 degree, we are going to find sine 30 degree over 2. And now look at the half angle identity I gave you before. Sine half of the angle, depending on the position of the angle, either it's positive or negative. In our case, 15 degrees lying on the first quadrant, so I solve positive. And then square root of 1 minus cosine of the angle. And then we divide it by 2. So on the top, we have the angle 30 degrees. So our formula is positive 1 minus cosine of that angle we have at the top. We divide that by 2 and then to the square roots. That is the formula. It's 1 minus cosine of the top angle, whole thing we divide by 2, whatever we have, that is under the square root. So we have 1 minus cosine 30 degree. Let's go to a triangle and see what is cosine 30 degree. 30 degrees here, cosine is adjacent over hypotenuse. So adjacent is square root of 3, hypotenuse is 2. So cosine 30 degree is 1 over square root of 3. Change the color to this cosine 30 degree. We found that is this one, 1 over square root of 3. Now we're going to divide everything by 2 and then take the square roots. It says don't use the calculator. So without calculator, we have to simplify this. In order to simplify, we need to have the same denominator. So multiply top and bottom by square root of 3 on 1, and we get square root of 3 minus 1 over square root of 3 on bottom. And we are dividing the whole thing by 2. And then to the square root. In order to simplify more, we are going to keep the numerator, change the division sign to multiplication, and we're going to flip our denominator. So we have square root of 3 minus 1 over square root of 3 times 2 has an invisible 1 below that. So when you flip, it becomes 1 over 2. Finally, when you multiply top to bottom, on the bottom we get 2 square root of 3, and on the top we have square root of 3 minus 1. Square root of 3 minus 1. And now we have no idea how much is this without using calculator. So this is our final answer. Any question? Oh, yeah. So you have one question to do by yourself. How did I find 15 degree? So we have no idea what is 15 degree. The unit circle doesn't have 15 degree. Or the table, the special table doesn't have 15 degree. Or the two triangles we work with, they don't have 15 degree. So none of them have 15 degree. So without using calculator, we have no idea what is 15 degree. It doesn't matter what 15 degree, sine 15 degree, cosine 15 degree, tan 15 degree. Any trig function for 15 degree, we have no idea what is this. So our goal is to use anything that you already know from either the unit circle or from the special table or from the special triangles. So the hint they gave us here is that they are telling us that, hey, use half angle identity. Half angle identity means, can you think of an angle? If you take half of that, it becomes 15 degree. So 15 degree is half of which angle? Or half of which number? 30. So we use is 30 over 2 half. So this 15 degree here you have is same as it's half of the 30 degree. Why do you care? Because when you have half angle, they have a formula. Half angle for sine, whatever angle, so half angle for sine, whatever angle you have on the top, that goes with the cosine. Oops. So let me write it here. The half angle for sine, oh no, it's freezing. The formula says it's 1 minus cosine of that angle, whatever you are taking half of. And then whatever answer you get, that is divided by 2. Then to the square root, and then depending on your position of the angle they give you, either the answer will be a plus or the answer will be minus. It depends on the position of the angle. So the angle we found on the top is 30 degree. That's why this one is 30 and this one is 30. And then we use the triangle to find out what is cosine 30 degree. And then we just did algebra. Okay. Any other question, Jody? No question. So you left with one more question on the worksheet, but this is same as question 2 or 3. Question 2. It's an interesting question. You're gonna relate whatever is given with any of the identities and then see which identity makes sense. They give you the hint already. They're telling us that you should look at the double angle identities. One of the double angle identities will be related with this one. Which one? And then when you simplify, what do you get? Just like question 2. Okay, thank you everyone for being here. Any question from anyone before we leave? No question? Okay. Thank you. Have a good day. Wonderful. If you have any question, feel free to email me anytime. So bye everyone.